I didn't push the document camera button. All right, now another reason that you need to fall forward, or fail forward is an overstatement, because we had a good exam and only a few of you literally failed, and maybe they already dropped, and that's why the audience is a little sparse today. But especially for the content coming up, chapter 5, elasticities, you really need to figure out how to become a more efficient studier. Because from past experience, I can tell you that this is the chapter that's probably going to challenge you the most. I don't particularly understand why it is. Maybe because there's a little bit more math involved here, although it's simple math. Maybe there's a little less memorization going on here, and you have to actually know more things and do more things. I don't know. But I can tell you for a fact that students struggle with the elasticities, and they struggle in everyone's class, not just mine. So I guess I'm exonerated from being the reason for that, but to some extent, I am. I'm sure there's a way that I can figure out and to get better at it, and I'm going to try. But you need to be on your guard to be even a more effective student than you've been in the past, because the material is going to get harder, and starting with this chapter. By the way, I notice as I come in that some of you are not exactly getting ready for dealing with whatever's coming up here. I see your laptops and your phones and whatever. That might be one of the lessons you might want to learn from whatever questions you missed, especially if there was a lot of them. Might be a good idea to spend from 8:15 to 8:30 in here kind of skimming the material and kind of getting familiar with some of the terms. Because if I use terms, or they're up here, and you didn't get a chance to read the chapter yet, or it was a little while ago, you'll hear words that you don't understand, and suddenly you'll be confused. Maybe if you get here before 8:30, you might want to give a quick look to some of those. And kind of get your head into the game, so to speak. That's what I spend my time on between when I get here and when I come down here, as I just keep going over the material back and forth. And now what am I going to say, and what am I going to do? Just kind of getting my head into the game. Some days more than others. I understand why sports teams that win NBA championships or Super Bowls still have a stink-up day every now and then. We have good days and we have bad days, and hopefully this will be a good day. All right, so here we are. I'm gonna leave it in this mode so I can go back and forth with the not the slideshow mode. It's big enough there, I think, and so we'll move on with it. Is that big enough? Yes, no, in the back there. Can you read that? Nobody's going to say anything. All right. So nobody said anything. Like, I can't see that, so we'll leave that up there. And again, you have the thing to copy from the BB Learn, Chapter 5, and I recommend that you do that, so you take the notes you need to take, but you don't write down things that you already have written down for you. All right, so we're talking first about the price elasticity of demand, and the idea is not that complicated. The idea is that, sure, the price increase causes people to buy less. The elasticity issue is, well, it matters a lot how much less. So we need a way to estimate that in a rigorous, understandable fashion, and we need, well, we don't need, but we can use that information for all kinds of important things, like if you're in business, whether to raise or lower your price. That's kind of a big deal, right? It's not obvious in business how much you should charge, and it's not obvious in many cases whether the amount you're charging is too much or too little, and whether you should raise it or lower it. The elasticity is kind of the secret piece of information. There are businesses that estimate elasticities, price elasticities of demand, and they charge a pretty penny for it, because it's a critical piece of information. Right? If the price elasticity of demand is low, what does that mean? That means that if you raise your price, the amount you sell won't fall by very much. That's a big deal to know that, especially in advance, right? What happens if you didn't know that in advance and you're in business and you raised your price and your quantity demanded fell by a lot? Oh, you say, whoops, I better not do that. Well, by then you might have lost them forever. They might go to one of your competitors and get used to shopping there. Whoops, maybe you better have thought about the price elasticity of demand first. You know that most retail businesses, or I don't know most because I haven't surveyed them, but a lot of retail businesses practice the 100% markup rule. In other words, whatever price they get it in from their retailer, they double that, and that's the price they put it out on the shelf. Okay. We as economists can prove that maximizes their profits if the price elasticity of demand is 2. Only if it's 2. If it's anything other than 2, the 100% markup rule does not maximize their profit. It's kind of dancing on the head of a pin, right? Okay, so you could point that out to somebody in business and think, ooh, maybe I better hire you, right, with your economics degree or business degree. They're smart. Maybe I better hire you to figure out what the elasticity is, because I'm not sure it's exactly 2.0. It might be 1.5 or 2.5. And it might be one number in the long run and another one in the short run, which is pretty important too. By the way, I am relying on the fact that most of you have at least skimmed your book, because I'm going to go through this stuff in the slides. I'll go through all of them, but I prefer a more conversational tone, with the underlying assumption that you've read the chapter and you're not utterly unfamiliar with what I'm talking about. Okay? One of the things that affects the price elasticity of demand is the time horizon. And this is a duh factor once you think about it a little bit. Right? Price elasticity of demand, what is that? How much response there is to change in price. Well, that depends on how long people have to think about it, right? Now think about gasoline. Remember, the book goes to oil a lot. Think about gasoline. If the price went up tomorrow, a fair amount, you probably wouldn't change your purchases of gasoline very much, because you're pretty much stuck in terms of what vehicle you drive, where you have to go for your personal business and your classes and all of that, where you live. None of that can change very fast. Okay? So, the price elasticity of demand for gasoline is very, very low in the short run. And not all that high in the long run either, but it's higher in the long run. Why? Because in the long run, you can change all of those things. You can decide, at this price of gasoline, maybe I better live closer to UTSA. Maybe I better live closer to work so I don't have to drive as much. Maybe I better get my car tuned up more often. All of those things you can do in time that affect how much gasoline you demand, your quantity demanded. But in the short run, none of those things are very much available. Maybe the tune-up. Okay, price of gas, I better go get a tune-up. You can do that fairly quickly. Except a lot of people will think of the same thing. And you may go, whoops, kind of a long line at the shop to get a tune-up. Maybe I better not do that. At least not now. That can happen. And then the tune-up shop says, whoa, where's, oh yeah, the price of gas, that's why there's so much more business. Can raise my price. All right. So a little bit of conversational stuff there, because I don't want to read PowerPoint slides to you. There's the information that we're discussing. Okay, so here's a basic point. In terms of a visual cue, a visual clue, the flatter the demand line, okay, the more the response to price change. Okay, and you can demonstrate it as this slide does. Now, the way to strictly demonstrate that, and that's strictly true, is if you have demand lines intersecting at a point. At that particular point, the price elasticity of demand is higher for the flatter line. Okay? Again, you can see it on the slide. If you raise the price from $40, the initial price, to $50, along the flatter line, the quantity demanded changes from what? From 80 to 20. Whoa, there's a big change. Okay? Whereas on the steeper line, it only changes from 80 to 75. Okay? So a much smaller response is what a steeper demand line says. Okay? Remember, it's a model, so when you draw the line, that's what you're modeling. Okay? You draw a line steeper, a demand line steeper, what you're modeling is low responsiveness to price change. If you draw the demand line flatter, you're saying, oh, the model that I want to create is of high responsiveness to price change. Now, I say that the elasticity is lower for the flatter line compared to the steeper line at a particular point, only strictly speaking at a particular point, because the elasticity itself varies from one point to the next on the line. Okay, so only if they have only at points in common is that strictly true. But again, all else equal, the flatter the line, the higher the price elasticity of demand. Okay, you're modeling greater responsiveness to price change with a flatter demand line. Okay, the point about the point and the elasticity, that comes up again later on. And I'll refer back to this slide. This is slide number 3. All right, so there's what I was just saying about gasoline a few minutes ago in the conversational tone. Okay, I list here. Got it. I didn't get into item number 3 or 4, but I did get into those first 2 items. Okay, so the price of gasoline goes up in the short run, within days, maybe even weeks. There are few substitutes that you can move to offset your purchases of gasoline, to do the same thing with something else, right, to make a substitution. And actually, I did get into 3 of those, because I think most of us, given the circumstances that we placed ourselves in the short run, gasoline's a necessity, right? We've got to move around. We've got to get to certain things, and they're not within walking distance of home, and the bus may not be convenient. So it's bordering on a necessity. Okay, so that's another factor. Some things that are harder to do without. Okay, we can't just decide, okay, well, we don't have any substitutes, we'll just do without. No, that's not an option typically for gasoline, because we do have places we have to go that are not within walking distance. Okay? Now, the fourth one, no, I didn't get into that with the gasoline example. But what does that mean? That just says if something's a tiny fraction of your budget and the price of it goes up, you're going to say, hey, it's not worth the brain power to think about doing something about it. You know, if the price of toothpicks doubles, okay, are you going to use a lot less toothpicks? No, it's such a trivial part of your budget. An extra couple pennies for toothpicks is not going to get you very excited and get you starting. You know, what can I substitute for toothpicks? Oh, I could use pieces of whatever, slivers from the wood shop. Well, yeah, but it's not worth bothering with to save a couple pennies on toothpicks. All right, so again, going over the gasoline thing one more time. In a short amount of time, there's not a whole lot of ways to get around other than to put the gasoline in your tank. So not very many substitutes, and they're not very close substitutes either. There's a big difference between other ways to get around and getting around in your car, putting gasoline in your tank. Now, time horizon, that's a big deal, because then there are more substitutes. You can buy a more gas-efficient car. Well, that takes a little while, right? You don't want to just run out tomorrow and buy a new car. It takes a little study, a little bit of research to get the right car at the right price. So that's a long-run thing. You could move, as I said moments ago. You could relocate. You could change jobs. Okay, you could recreate in different places. Okay, those are all things that can change given time. So your responsiveness to that change in the price of gasoline will vary considerably depending on how long of a time horizon we're talking about. And as I said a little while ago, that's a really big deal if you're in business, because you may raise your price and think, whoa, that was a good idea. The sales hardly dropped at all, and we're making more on each one. That was a good idea. And then, whoops, a couple weeks later, and your sales have dropped a lot more than they dropped initially. That's because you made your customers mad, and it just took them a while to figure out what their alternatives were. Okay? And then you may have lost them permanently. Okay, questions, comments, thoughts? Remember, that's why we're here. We're not here to convey information. We are here to clarify that which is not self-evident from reading the book. This is an uncomfortable place to sleep, so if that's your need, you may wish to do that elsewhere. Someone back there sleeping. I have a cartoon, by the way, speaking of that. It's a dictator tossing and turning in his castle. He can't sleep. Okay, several frame cartoon. And about the fourth frame along, he says, "Call me the economist." Okay, economist comes down, starts lecturing, putting stuff on the board. Anyway, the joke's about economists. It's fun. All right. So I think we just covered this slide. Okay, but it's there for you to look at and get a sense of whether you think we covered it. Right? We covered that in the discussion of the gasoline situation. And the price of something goes up, and you think, well, what can I do to do the same thing but with something else? Okay, to meet the same want or desire, but with a different product, or to do without. But mainly the issue here is if the price of apples goes up, I like a little bit of fruit in my lunchbox. So maybe I could do with pears or oranges or something else instead. Consumption substitutes. Okay, time horizon. Again, I think we covered this on the gasoline rant. Wasn't a discussion because none of you were saying anything. Shouldn't call it a discussion. I was talking, no one else was, which isn't good. Remember, what was it, last time we actually had some discussion, some back and forth that lasted about 5 or 10 minutes. That was so cool. More, please. All right, I think we discussed the necessity versus luxury thing. Okay, if it's something that you have to do, okay, maybe there are different ways to do it, fine, there might be substitutes. But if it's something you have to do, all else equal, it's, your response to change in price. Let's say you're talking about medicine. If you need it, literally, for your life to continue or avoid massive pain, it's a necessity. And probably your only option is maybe to alter the dosage a little bit. And you'd be surprised. People do that, right? So there really aren't very many things with a vertical demand line where it says price doesn't matter, the amount is going to be the same. Certainly not for the market as a whole are there very many commodities like that. For individual people, there are a few. Okay, because any less or more dosage of something, you're dead. Okay, so price changes, pay up. But there aren't too many of those things, and I've read about medicines that you would think are absolute necessities, and the price of them goes up, and people cut back their dosage a little bit to try to reduce their quantity demanded a little bit because of the higher price, with sometimes not so acceptable consequences. Okay, here we discussed this with the toothpick example that I gave. I'm asking, not telling. Okay, so here's a summary, of what we just talked about. Again, asking, not telling. More inelastic. What does that mean? That means less responsive to changes in price. Remember, studying includes translation. See, there's that Cajun thing that I warned about, doing more of that. Translation, right? Changing the words that you read and that you hear into other words that mean the same thing. Okay, that ingrains it in your brain, and then it's not recall, but understanding that's going on. Okay, more elastic means more responsive. Quantity demanded is more responsive to changes in price. All right, so it's a number we want, in many cases, an exact measure of how responsive quantity demanded is to change in price. So, what are we going to do to crunch the number to have it be especially meaningful to us? Well, what we do, and what we do for all elasticities, go ahead and write this down. It's a funny looking E. Okay, as economists, we like the Greek alphabet. I was tempted to do X and Y. The reason I didn't do that at the last minute is because somehow in economics we get our wires crossed from what's normal. What does that mean? P and Q on the graph, right? Usually Y on the y-axis is the thing being caused, okay, the effect, and then the cause, that's usually down here, but we got it backwards. Okay, so if I put X and Y up there, you might get confused and think, oh, changes in quantity change price. Usually we think of it the other way around. It's the change in price that change in price changes the quantity. So for a generic description of an elasticity, see, this is just any elasticity of any kind. Price elasticity of demand, income elasticity of demand, cross-price elasticity of demand, price elasticity of supply. Cross-price elasticity. There's a gazillion elasticities. Economists love elasticities. Some economists even configure their multiple regression equations so that when the computer spits out results, they're elasticities, which is a mistake most of the time because it means you have to tell the computer that the data are related in certain ways that they're not related in order to get an instant elasticities. But anyway, we love our elasticities so much that we sometimes do silly things. So all elasticities are unitless numbers that result from dividing two things, effect by cause. Effect in the numerator, cause in the denominator. Okay, so for example, let's say this is 3. What does unitless mean? It means it's not $3 or 3 inches or 3 miles or 3 tons. It's just 3. That's one of the ways you show you're ignorant as an economist or somebody that purports to know economics. You say, oh, the elasticity of demand, the price elasticity of demand is $3. You blew that one. No, it's just 3 or 5 or 7 or 0.5. And so, by the way, sometimes, as it says in the book, sometimes we ignore the sign, right, plus or minus, because we know what the sign is. What matters is how big the number is, right? We know if this is a price elasticity of demand, we know the numerator and denominator are going to move in opposite directions. So we know we're going to get a negative number. So we can ignore that aspect of it, unless we're using the elasticity in a formula to find something else. Then we better not forget that it's a minus number. But in just discussing what the number is, we can say, the elasticity is 2 or 0.5 or whatever it happens to be. And okay, it's minus 2. Yeah. Okay? So all elasticities are the ratio of 2 percentage changes that are cause and effect related. Right? Finding an elasticity for things that are unrelated is just nonsense. Yes? All elasticities are the ratio of 2 percentage changes that are cause and effect related, with the cause on the bottom and then effect on the top. Okay, so if somebody says the price elasticity, says the price elasticity of demand is 3, you know that a 1% change in price will cause a 3% change in the quantity demanded. Okay, that the effect is 3 times the size of the cause. Yes?
You want to show an example of that?
Of what?
What you're explaining right now?
I think I just did. I'm not trying to be snotty. That was what did you mean by an example other than if the price goes up 1%?
A visual description rather than verbal.
Oh, okay. Okay, so if this is 1, and that's 3. I know that's what I just said in words.
Is it going to be as basic as that?
Well, you have to. The only part that's not basic is that you have to find a percentage change, and that's pretty basic too. Okay, so for example, how would you determine that the price change was 1%? New minus old divided by old. Right? That's how you find a percentage change in anything. Right? Let's say your wage goes up 50 cents an hour. How do you figure out how big a percentage change that is? New wage minus old wage divided by the old wage. $10 an hour minus $9 an hour over $9 an hour, 1 divided by 9, 11%. Okay. So I'm not trying to be snotty and what do you mean by an example, because I just didn't know what you meant other than... Later on the slides and up here, we'll have some numbers that do some more of that. But maybe that was the reason you asked. Maybe it just seemed too trivial. Is that all there is to it? I would like you to believe that it is, that the math part of it is trivial. Sadly, I think that a lot of you let that part of it bother you. People have these little messages going on. Oh, I'm bad at math. Oh, it's math. And then they just shut down. Whoops, I hit a nerve there a few places that we don't want you playing poker. Some people, it doesn't matter what you say. I have this person in one of my other classes sits right here in front of me. And so I look at him every once in a while just to try to get, how am I doing? His face is just blank as blank can be. Most of you should be playing poker from time to time. I don't know what your tell is, as they say in poker. I can't tell by looking at you whether you're getting what I'm saying or scared to death, deer in headlights look. I can't tell for most of you. So I do appreciate those of you that I can tell. Can look at you. Oh, okay, it's working more. And by the way, more of this would be good too. Feedback, discussion, that's more important than going through PowerPoint slides. There's nothing on these slides that isn't in your book. I'm using the slides from the authors of the book. Now, I edit them some, but not much. Okay, the editing process is my way of making it sink into my head. See, I know, same thing that I tell you, that if it's just my eyes going over stuff, getting ready for class, I'm not going to retain much of what I do. But if I get into it and say, there should be a comma here, and there should be a word here, an adjective for this, then I'll get more into it, and it'll stick. So, same advice for you works for me. Okay, so appreciate that. Keep at it, and if I don't get it, do your Sam Donaldson thing. Whoops, I'll fall over the chair. Okay, so here we have the specific rendition of this. Okay, the price elasticity of demand means that in the top, Z is the percentage change in the quantity demanded. And on the bottom, where I have percentage change in Y, it's the percentage change in price. Right? So this is generic for all elasticities. Any elasticity of any kind. They're all the ratio of percentage changes. Okay? This particular version, price elasticity of demand, is probably by far the most important and useful elasticity to know and use and understand and pay somebody, if you can't do it yourself, calculate it for a business that you might be running. Okay, and you see the little triangle that I used over there? You see it defined there in the bottom. It's just a shorthand for change in, the Greek symbol delta, change in. All right, so it's just E sub D, price elasticity of demand is that ratio of percentage changes. Okay, so here's another version of the example. I had three. Okay, so another way of getting the 3, here's what might be too trivial. Okay, so maybe this was. Okay, maybe you observed that an 8% change in price caused a 24% change in the quantity demanded. Well, that means the price elasticity of demand is 3. Okay, it's the rate that matters. Okay, just like back in chapter 2 where we were talking about comparative advantage and opportunity costs, you have to do the division to get a rate. Now, it turns out that there are 2 ways to actually do the math. One is called the point formula, okay, and that's appropriate for small changes in price. And then there's the midpoint formula that you probably should use for large changes. And I noticed in going over the test bank the last couple of days, if it doesn't say there, and I don't think I picked any questions like that, but if I did, to get distracted, if I did, use the midpoint formula if it doesn't say which one to use. Okay, and we'll get to the midpoint formula here in a couple of slides. Okay, so you see there on the slide, the elasticity literally is minus 0.5. But what is important, because we understand that one going up makes the other one going down, is the size, right? Or in absolute terms, just 0.5. It means that the change in quantity will be half as big as the change in price that caused it, measured in percentage terms. Okay, so a 20% change in price will cause a 10% change in the quantity demanded. Okay, very important information if you're trying to sell something and make as much money as possible doing it. And you tell me, well, make as much money, isn't that just greed? Most of the time in our hyper-competitive economy, maximizing profit is just barely enough to not go broke. Okay, so you better be maximizing profit if you expect to stay in business at all. Most of the time it's not about raking in more money or shaking people down. Yeah, there's some businesses that are able to do that. They're monopolies, or they don't have much competition, or they're just in it for the short run. But most of the time, maximizing profit in a competitive market means just barely getting by, barely covering your opportunity costs. Something we'll get into a little more detail later on. Now, I kept this example. I was tempted to edit it or delete it because there's one aspect of it that's a little bit bizarre. Maybe you can tell me. We're going to stick with the math that's in the article here. Okay, so there's a 70% increase in the 70 cent per pack increase in a state's tax on cigarettes. And let's think about this. If the price elasticity of demand is high, putting that tax on it will lower the amount sold by a lot, right? right? Price elasticity of demand says high price elasticity of demand means there's a big response to changes in price. So the increase in the tax might not actually even get us more money. And they discover this the hard way sometimes. People that don't know even basic economics are naive enough to think that anytime you raise a tax rate, it will bring in more money. No, that's not always true. You know, right now with the tax rate being about 40% on highest incomes, we make more money from the rich people now than when the highest tax rate was 91%. Yeah, it was in the 1950s. And it was a big deal when it was cut to 70% in the 1960s. Each time that we did that, we lowered the highest rate on the highest incomes. We made more money from those people, taxing them at a lower rate. Well, that's an indication of elasticity. There was more income reported at the lower rate than at the higher rate. There was less tax evasion, tax avoidance. So there was, and we're not talking price elasticity, but just as give an example of making something more costly, in this case work or income, making it less costly, there was a lot more of it. Okay, so much more of it that we made more money on the 70% rate than we made at the 91% rate. And again, in the 1980s, Ronald Reagan cut that down to 50% in 1981. That still seems awfully high to me, but anyway, it was lower than the 70 that it was before he came into office. And again, that made more money from the rich people. You know, we did it again in 1986. We lowered the top rate from 50% to 28%. And again, that brought in more money from the rich people. See, those rich people aren't rich for nothing. They're pretty clever about how to dodge taxes. So if you give them an incentive to do it, they figure out, I'll put my money in another country or someplace else. Or I just won't do as much work as I otherwise would and won't have as much income to report, take more leisure. We make more money now from rich people than we ever have. Rates are back up a little bit. The maximum rate in the late 80s was 28%. That's the highest marginal rate that anybody paid. Remember marginal from the first chapter, the change in something if you do one more or something. Yeah. So I think the top 1% of income earners pay 40% of the federal income tax. Yeah, and the top 10 or 15% pay like 80% of the money. The bottom 50% in terms of earnings pay almost nothing. Yeah, so our taxes have gotten less progressive. Our rates are not as high on the higher incomes as they used to be, and they bring in more money from rich people than they used to. Again, an indication of elasticity in terms of reporting income to be taxed. Okay, back to the price elasticity of demand. I've stalled a little bit to give you some of you, but doc, a chance to raise your hand and say, what's wrong there in this example? But we're going to stick to it just because it's written up for us. 70 cent per pack tax in. See, whenever you see something like this, part of being a professional, I don't mean right now because you're students, but you're practicing to be professionals, is to always kind of fact check the numbers for reasonableness. Because the first check on anything is whether it's believable. Okay? Whether a rational person would believe it. When I run a regression analysis, which is a statistical thing, in case you don't know exactly what that is, and I get a result that says a 10% change in this will cause a 2% change in that, the first check before I report it to anybody else is whether that's believable or not. If I say to somebody, if you raise this 10%, that'll lower this 2%, they look at me like, no, I don't think so. Not reasonable, not rational. By the way, if you forget the minus sign and the elasticity, and you plug it into an equation, I haven't presented it yet. If you forgot the minus sign, and you use the result, you would tell your boss to charge less than he pays for the product. The bosses look at you, wait a minute. I just bought this from the wholesaler for $5, and I hired you from UTSA with your business degree, and you're telling me to put it on the shelf for $3? Where'd you go to school again? UTSA, Yeah, okay, let me run this by me one more time. We paid $5 for it, and you want us to sell it for $3. No, sorry, I don't buy it, even with your business degree from UTSA. That is a result you'll get by forgetting the minus sign in that equation. You plug the minus sign in there, it'll say, get it from the retailer for $5, put it on the shelf for $8, okay, or more than $5 for sure, right? You have overhead to cover, right? Out of the margin on the sales. Okay, does anybody see what's kind of weird here? Bingo! You see, we fact checked it, right? You look up here and you say, according to this article, right, by Sarah Voss. I call up Miss Voss and say, are you sure about that? Are you sure that a 70% increase, a 70-cent increase in the price in a tax will make something cost 88 cents more? No, in fact, in the short run, you can't pass on all of the tax. A tax will cause a less than whatever the amount is increase in price, not more than that. But anyway, we'll go with these numbers. We won't challenge them here. But yeah, that's right. It just doesn't fly in terms of believability that a 70-cent tax on cigarettes will cause the price to go up 88 cents. If anything, less. Why less? Because people won't buy as many cigarettes at 70 cents more, right, than they did before. So at the original price after tax, there'll be now a surplus. Let me diagram it up here. Let me just quickly do that. I do too many air graphs. But okay, so here we have, here's the supply without the cigarette tax. Here's the supply with it. Here's the demand. Okay, here's the original quantity. Okay, so now, let's say that, what is it? Now, let's not use those numbers. Let's say this is 470. This is 4. Okay, something like that is what would happen. Okay, the day after, the price is 70 cents a pack higher, right? Seller's got to pay the tax. But see, at this price, the buyers don't want to buy as much as they used to. Okay, so now there's a surplus at 470, and the new equilibrium will come in here somewhere between 470 and 4. And then some of the cigarette producers, we discussed this already, some in terms of the profit being the driving force in the long run. At 440, some of the cigarette makers will say, I only get to keep 370 of that, right? 440 minus the 70 cents that they owe in tax. I can't make it anymore at 370. I could make it at 4, so I'm leaving the business. So the supply shifts further to the left. But the short run, that's what we have right there. All right. So there's the facts. There's the number crunching that is involved there. Okay, to find the elasticity. We've got to find the percentage change. So we take the estimate of the percentage change in quantity that somebody had to determine via research, and according to that research, the effect on youth consumption would be a drop of 16.6%, and the adults who are addicted, they'll only decrease by 4%. And so how do we do the price? The percentage change is new minus old divided by old. That's how you find the percentage change in anything. Okay, so 455 minus 367 divided by 367 is the percentage change, which is 24%. Okay, so don't anybody get intimidated by finding a percentage change. Okay, it's just not allowed, frankly, for somebody in college to get freaked out by having to find a percentage change in something. If it does freak you out, don't hang your head or run and cry or anything. It just says, hey, you dodged your math responsibilities long enough. It's time to get after it and get over that phobia and get over that speed bump. All right. So then we've got our percentage change in price. That's 24%. So for the youth, we take the percentage change in quantity, the 16.6, divide by 24, and we get a 0.69 elasticity. It's still inelastic. Anything below 1 in absolute value is inelastic. Means low responsiveness. Change in quantity is less than the change in price that caused it. But for adults, really inelastic. Right? 4% divided by 24%, just 0.17. A very, very low elasticity. Now, this is another thing that I'm, let's use these examples that are a little weird to prompt discussion. That's another thing that I have a little bit of an issue with, is an elasticity that low even for cigarettes, especially if it's a state tax. Why is that? Wouldn't matter if it's a state tax versus a national tax, wouldn't it? What are the smokers in Kentucky going to do every time they're not somewhere other than Kentucky? I mean, every time they're somewhere other than Kentucky. See if the cigarettes are cheaper, and if they are, load up. What if you live just on the border of Tennessee, and they're cheaper in Tennessee? Then you buy your cigarettes in Tennessee, right? So the notion of an elasticity that low for something with close substitutes, cigarettes in other places, doesn't compute. See, it's another one of those things where you have to bounce your common sense off of what somebody says will happen and say, no, I don't buy that, literally. Many states have done this, by the way, said, we need more money to pay the government's bills. We don't want to tax everybody. That would hurt votes. We'll just tax the smokers. By the way, I'm not a smoker, so I'm not defending smokers. I'm just explaining something that's happened many times. And they said, we'll put demand for cigarettes is inelastic because the adults are addicted. Well, they may be addicted to cigarettes, but they may not be addicted to cigarettes sold in your state. Right? People are pretty mobile. So when they're somewhere else anyway, they'll load up if they're cheaper, or if they're near the border, they'll cross the border and buy their cigarettes somewhere else, because cigarettes in another state are close substitutes. Remember, that's number one in terms of determining elasticities. Cigarettes sold in other states is a very close substitute. They're identical, right, to the cigarettes sold in your state, right? The same brands are available everywhere. Most of the same brands are available everywhere. Okay, so that 0.17, I think somebody found an elasticity for national cigarette consumption with respect to changes in price and plugged it in for the state. That will turn out to be a big mistake because they will way overestimate how much revenue that the cigarette tax will produce, because a lot of Kentucky smokers will go out of state and buy their cigarettes, close substitutes. Okay, so here's that slide that I inserted in with the author content. All demand lines have elasticities changing from point to point. All demand lines, no matter how steep they are or how flat they are, at the very top of the line, let me see if my laser pointer is working. Wow. At the very top of the line, right there, the elasticity is infinite. Why is it infinite? Okay, think about that. Don't memorize. Why is it infinite? What does that mean? That means if you charge a price that high, you have no sales. So if you lower the price just a teensy-weensy bit, okay, a very low percentage change, right, a small change in a high price is a very low percentage change, and you'll have an infinite increase in sales from zero to something more than zero, right? So the elasticity at that point has to be infinity. Again, it doesn't matter how steep the line slopes down from there, it always starts at infinity. And it's always exactly 1. I kept the minus sign, but it's always exactly 1 at the midpoint. And it's always 0 here at the end. So for any given point, the elasticity will depend on the slope. But for any given line, the elasticity will always vary from infinity at one end to 0 at the other end. Now, so suppose an economist comes along and says, what's with this? And says, your price is right there. Okay, again, you're running a business, and you're trying to figure out whether your price is too high or too low, whether you should raise it or lower it to make more money. And the economist does his statistics, and he or she estimates the demand line and says, your price is right there. You're on the inelastic portion of the demand line. You need more information than that to know whether to raise or lower your price? No. Better raise it. Now, again, there's that time horizon thing. It may be different in the long run. But at least for the short run, raise it a little bit. Okay? You're on the inelastic portion, right there where the word demand is. The inelastic portion, what does that mean? This is how you need to be studying. Inelastic, what does that mean? It means if I raise my price, quantity demand, it won't go down very much. Oh, like if I raise my price, I won't sell that much less. Oh, raising my price will make me more money, more revenue, right? If you raise your price and the amount purchased doesn't change much, you'll have more money coming in. That's good, right? Now, that's not the whole story, right? Profit is total revenue minus total cost. Can you tell which way the cost is going to go? Again, this may seem mysterious to you, but it's duh. Right? Unlock the brain, it's duh. Trust me on that. You raise your price, what's going to happen? Quantity goes down, right? It costs less money to make less stuff, right? Isn't that duh? Right? Total cost is obvious. How it's related to quantity is pretty obvious. Not how fast necessarily, but making more will almost always cause your total costs to rise, right? It takes additional resources to make more. And making less means you save at least on some materials, if not also some labor and capital. Okay, so let's see. Let's go back to this again here. I'm trying to get you to think more and, stenography less. Okay, so you determine that your price that you're selling at right now is on the inelastic lower half of your demand line that the economist that you paid found for you. So that means if you raise your prices at least just a little bit, okay, again, because of that long run versus short run thing, your revenues are going to go up and your costs are going to go down, right? Because you are going to sell less, not a lot less, but less. Costs will be lower and your revenues will be higher. No brainer, right? Once you let that sink in, you say, hey, get out there and change those price tags right now, right? Raise them. Now, how much? That's a short run, long run thing. Okay, but at least raise it a little bit. Okay, well, I know you haven't gotten into the total revenue aspect of it yet. That comes up, but again, I'd like to do this conversationally, and so, let me talk about something else that's on here. Let's say you have a demand line like this. The upper half is up here somewhere, right? The elastic half. Okay, so more than likely where the supply intersects the demand is going to be somewhere on the inelastic part. So see, that says if somebody doesn't have any competitors, they better raise their prices a lot to get off of that inelastic half. Anytime it's inelastic, you should raise your price. Okay, so you raise your price till it's not inelastic anymore, right? Till the price elasticity of demand is above 1. Now, suppose suppose the economist tells you your price is here on the upper half. Does that mean lower it? See, here's where economists become two-handed. Some people hate that. On the one hand, Mr. President. On the other hand, Mr. President. Tell me, what's going to happen? Well, on the one hand, Mr. President, this will happen. Anyway, President Truman got so frustrated with advice like that when he was president in the late 40s and early 50s. He actually scribbled up a little ad. I guess he had a good sense of humor. I want a one-handed economist. Please apply for a job at the White House. All right, on the upper half, if you lower your price, okay, again, learning elasticities means you need to do thinking like this. You will not succeed by memorization. It's not going to happen. Some of you, as you determine why you missed a question on the exam, or many of them will determine that, you should have remembered that one. Why didn't you? Because you didn't know what you were talking about. You didn't know you didn't understand it. And so your brain had a bunch of disassociated, memorized facts in it. You didn't know when to pull it out. You go, oh man, how did I miss that? I remember, but you didn't understand it. All right, so you're up here on the elastic half of the line. You lower your price. That means the quantity demanded is going to go up a lot. That's what elasticity means. So by lowering your price, you'll increase your revenue. That's good, right? But by lowering your price, you'll increase your quantity. Your costs will go up. Whoops. See, on the elastic half of the demand line, price changes move cost and revenue in the same direction. See, that's the two-handed economist thing. Okay. On the one hand, Mr. President, the revenues are going to go up. Oh, but on the other hand, Mr. President, so are the costs. And that's why we do that marginal analysis that was in Chapter 1 and will be a big part of later in the semester. It depends on whether the additional revenue covers or doesn't cover the additional costs. Okay? Let's say that the lower price increases your revenue $100. Well, then it's a good idea if it increases your costs by less than $100. Right? The additional revenue is 100. As long as the additional cost is less than 100, you've added to the bottom line, right? Okay, so on the inelastic half, on the elastic half, inelastic half down here. On the elastic half up there, changing price moves revenue and cost in the same direction. Therefore, you have to do marginal analysis and ask yourself which one changed the most in order to know what to do. So you need additional information about the magnitude of the changes in order to provide advice. We'll get into all of this with some specific examples via the top hat questions here in a few minutes. I think we'll get there in time to do that before the period ends. Okay, so I think we covered this one, but again, I'm asking, not telling. Read the slide. See if you think this was covered adequately, and if not, please raise your hand, because that's why we're here. Didn't mention the term uninelastic. That's that 1 point right in the middle. The elasticity is 1. Right there, it's uninelastic, it's called. Elasticity is 1. Okay, it's kind of balanced on the head of a pin, right? 1 penny higher price, your demand is elastic. 1 penny lower price, your demand is inelastic. It's the revenue maximizing price. We'll see that in a minute. Does that mean it's the profit maximizing price? Typically not. The revenue maximizing price maximizes profit only if cost doesn't change when quantity does. Now, are there any such businesses where cost doesn't change with quantity? There are actually a fair number. Okay? So there are some exceptions to this notion of if the price goes up, the quantity changes, and that'll affect your costs. How about like a baseball game? Does one additional fan change the cost of the game any? No. So you should set the price, the ticket price, so to maximize revenue, right? Because the marginal cost, the change in the total cost with one additional unit sold is close to zero. How about a movie theater? Same thing. The cost of providing the movie to those in the audience is not affected by how many of the seats are filled. Okay, so there you should use the revenue maximizing price, which means the price at where the elasticity is 1. Okay, so here's where it gives you the midpoint formula. And it looks kind of intimidating, but it's not. And again, some later slides will have specific number crunching examples. The top still has the same thing, new minus old. Okay, that's what I mean by the top. Okay, the percentage change in both cases, before and after, new minus old. Well, I have old minus new. Anyway, same thing. You just get the same absolute amount either way. New minus versus old, new versus old. And on the bottom, the midpoint formula, instead of saying old, it says the average of new and old. That's all it does. Okay, so on the top, it'll say, suppose your quantity changes from 90 to 100. Okay, a change of 10. Okay, what's the basis for the percentage change? Well, in the point formula, it's 90, right? Change from 90 to 100. And the midpoint formula would be 95, halfway between 90 and 100. That's why it's called the midpoint formula. You should use that for big changes, right? The relevant reference for a big change is halfway between where you started and where you ended up. The relevant reference for the percentage change for a small change is just where you started. Okay, so again, with all the symbols and all that, because there's a lot of things there, it looks intimidating. No, it's not. You're finding a percentage change by how much was the change, and you divide it by either in the point formula where it started, or in the midpoint formula halfway between the beginning and where you ended up. Okay, so some numbers to process that with. There they are. I guess, see, when I studied that before class, I guess I must have remembered the numbers. Well, at least the top one's the 100 minus the 90. Okay, so 10 divided by 95 is 10.5%. What if you did it by the point formula? What would you get? 10 divided by 90 would be 11%. Okay, so think about the difference. That's how you learn too. Try it one way with the one formula and try it the other way with the other one. Say, how much difference does it make to use the one versus the other one to find an elasticity? See, then you'll know what a point formula means and what a midpoint formula means. For the percentage change in price, see, a change from 10 to 20, okay, is 10. Okay, and then halfway between 10 and 20, 10 plus 20 divided by 2 is 15. So that'll be a big change. 66%, 2/3. Say a huge change in price caused only a approximately 10.5 to 11% change in price, depending on which formula you use. Okay, so very, very inelastic demand with the midpoint formula, 0.15. Okay, now here we get into the revenue that I've already gotten into conversationally a little bit, so we'll just nail that down. Okay, the confounding, frustrating thing about revenue is that it's price times quantity, and those two things are inversely related. Right, the P times Q, that's duh. Right, but again, go over it in concrete terms. If we sell 10 of something for $2 each, $20, right? Duh. Okay, how many we sell times how many we sell each one for says how many dollars we'll have in the cash register. Okay, so that's all that's involved in total revenue. Again, as I said, the confounding, frustrating part is if we increase the one, we'll decrease the other one. And then it's a matter of which one changes the most. That's the elasticity concept to know which way the revenues are going to go. Okay, so to predict that in a business, you either have to be flying by the seat of your pants and just kind of groping around in a way to try to figure out what price you should charge, or you follow the 100% markup rule that everybody else is following. And you say, okay, what's what everybody else is doing? That's what I'll do. And then an economist comes along and says, yeah, that'll maximize your profit when the elasticity is 2, but not otherwise. You think, do I believe that a 10% change in price will cause a 20% change in quantity demanded? Because that's what you're saying. Right? If you have the 100% markup rule, what you're saying is that I believe that a 10% change in my price will cause a 20% change in my quantity demanded. Okay, if you believe that, then, but if you say, no, I don't believe that, then you better not be using the 100% markup rule. Okay, putting in those terms, then you have to think, is that what I believe about my customers? Yeah, maybe so, maybe not. Okay, so we got into this earlier when I did my little thing here with the laser pointer on that demand line. If the current demand is price inelastic, that means on the lower half of the demand line, right? That lower half is where the elasticities are less than 1. Then revenues go up and the price goes down. You see, those are duh situations. Revenue and cost move in opposite directions when you have price inelastic demand. What do I mean by a duh situation? If the demand is price inelastic, what happens when you lower your price? that revenues and costs are going to go in opposite directions. Your revenues are going to go down and your costs are going to go up. Hello? I don't think that was very good for your business. Right? Lower your revenues and increase your costs. Not smart. Okay? Or if you raise your price, the revenues go up and your costs go down. What took you so long? Okay, so in an inelastic situation, it's obvious what to do. Not necessarily how much, okay, because that depends on the long run versus the short run, but yeah, you know which direction to go with your price. If the demand is inelastic, as we said earlier, and by the way, I say that not to, you should have gotten that earlier, no, just to kind of go back to that discussion in your head. If the price is on the upper half of the demand line, price inelastic, then revenues and costs move in the same direction. So it's not obvious what to do. We need to know the elasticity exactly in order to know how much revenues will change, and then we better look at our costs, see how much those are going to change. Go back to that movie theater situation. If the demand is inelastic and we lower our price, if the demand is elastic and we lower our price, our revenues are going to go up, right? And unless the theater is full, we have other places, empty seats, our costs are not going to change for running the movie. And we have an extra benefit. We'll probably sell more popcorn and snacks at the snack bar. Okay? So if you're running a movie theater, you don't want to be charging a price where your demand is still elastic. Your price is too high. Lower the price. What price should you be charging where the demand is unit elastic? Because if you go past that, your revenues are going to go down. Your costs will stay the same. Again, it's assuming you have still empty seats, excess capacity. But you want to get as close to that unit elastic point as you can with a business like a movie theater. And maybe a teensy-weensy bit beyond that, contradicting myself now, I know, but I remembered my example with the snack bar. Right? Going past the unit elastic point as a movie theater, you're doing this two-handed thing again. You're saying, okay, if I lower the price a little bit more, yeah, that'll hurt the revenues from tickets. But it might be more than offset by additional sales at the snack bar. But you don't want to go too much past the unit elastic point because you keep lowering your ticket sales and the additional sales at the snack bar may not, at some point, won't make up for that. Questions, comments, thoughts? Let's see. Okay, we did the revenue thing. Let's go over and do a couple of PowerPoint. Let's do a few of these. Let's go ahead and do the attendance too before I forget. I keep forgetting to do that. The person that was sleeping left because she figured we were a more comfortable place to sleep. So she wasn't here anyway, right? In the mental sense. I understand why some of you are half asleep. Nothing against you. It may mean that you're trying to do too many things, but it's tough. I know, to pay for school and still do school at the same time. It's tough to be just one person when there's only two things to do: studying and employment to make money to pay for all of it. So it's another one of those marginal analysis things too. And at what point is there optimality between hours worked versus work foregone in order to have more time to study? Nobody wants to say they're here? Okay, want those devices fired up? We're going to do top hat questions here in a second, so you'll need those devices running for that. Okay, going once, going twice. All right, well, maybe only 44% of the people are here. Do keep that in mind, by the way, when you look at the test averages. People, for whatever reason, believe that their opportunity cost of attending exceeds the marginal benefit of being here. So, they may or may not be correct. Oops, got to close this first. Now, you should be able to do this calculation in your head, but don't be shy. Pull out your cell phone or your calculator if you need to. But I made the numbers so that you should be able to just do it in your head. Right? Because the starting point prices are 10 and the starting point price and quantity are 10 and 100. It's easy to figure a percentage change with that as a starting point. Now, one message of this slow start isn't, it's the first time you're doing it, so you're feeling your way along. But on the test, can't afford to be this slow. This can't be the first time on the test that you find an elasticities. Even if you know how to do it, if it takes you 5 minutes to get to there, that's an unacceptable cost from your perspective. All right, we've got more. That was moving up a little faster. All right, I understand the difficulties here at first, so let's just, I did a marginal analysis in terms of the time. Okay, I'll go to the report in a minute. See what I mean by doing it by hand, in your head? What's the percentage change in price? Just looking at it there. There's a $1 change in price compared to a $10 starting point. How big a percentage change is that? 10%. Okay? $1 versus $10, 10%. Okay, what's the percentage change in quantity? 20 more starting from 100 is 20%. Okay, 20 out of 100, 20%. Okay, 20% divided by 10%. Wow, all over the map. Okay, so see, here's that river in Africa thing again. Again, maybe this is just the newness of it. Okay, so, you have a little warning there. And let me remember to do this. Put it over there so you can have it. Go back to it. But, so maybe the river in Africa analogy isn't appropriate here given the newness of it, but a lot of you at least don't understand it yet. Okay? But I didn't remember seeing any hands up that said, "Doc, I don't get it. Explain that to me again." Or preferably a more specific question. Okay? So all elasticities are 2 percentage changes divided. Okay? The percentage change on the top is the 20% change in the quantity demanded. The percentage change on the bottom, the W, is the percentage change in the price. 20 divided by 10 is 2. Fishing for questions. Fess up. Okay, if you need more clarification, say something. There'll be many of these questions on the test. Yes? Okay, tell me which part of it. The percentage change in the quantity or the price or what? Okay, the quantity goes from 100 to 120. So that's a 20% change. Now, just the math of it, if you want to do that for practice, new minus old. 0.2, maybe that's the transition that some of you didn't make. You got to, from decimal to percentage, you got to move the decimal a couple over. But you could have done it both ways this way, and then you have 0.2 divided by 0.1, you still get 2. Okay, so this is a 20% change. Many times the math won't be easy enough to do in your head, so you take new minus old divided by old to get that percentage change. And the same thing for the price, you do the 10 minus 9 divided by 10. Okay, or 9 minus 10 divided by 10, either way. All righty. We have a couple more of these. Let's see. Okay, same numbers. See, it says spent / collected there. Well, total revenue is somebody's spending and somebody else's money coming in. All right, we're out of time, so class-wise. Okay, so what was the initial revenue? You were selling 100 of them at $10 each, $1,000. Okay? But it's not B because the total revenue, at the new equilibrium, you have the $9 price and the 120. So you multiply those, and that gives you A. Yeah, okay, the vast majority of you got that. Now, in our final moments here today, we have a problem in determining whether to do that or not, if that's our business we're describing, right? What's the marginal benefit versus marginal cost issue? The price decrease increased revenue by $80. It's a good idea if it increased cost by less than $80. It's a bad idea if the additional if the additional 20 units of output added more than $80 to cost. See what I mean by studying is getting to duh? Right? Once you put that in words that resonate, that's that translation thing, then it's like, well, duh. Okay? The trick, the key, since it's not duh very fast, is to put it in words that resonate. Oh, well, yeah, sure, if you do that. Oh, okay, yeah, sure. Getting to that is a matter of getting comfortable with the definitions of the words. See you Tuesday. Please go online and post your clarification wishes for exam questions.